Right now, engineering teams are under immense pressure to deploy artificial intelligence into their businesses. The instinct is to look around, find whatever large language model is currently considered the smartest, and wire it up to your app as quickly as possible. That makes sense when the entire industry is obsessed with benchmark scores and flagship releases. We have been trained to treat AI like a horse race, looking at leaderboards to see who is currently in first place. But look at this timeline of flagship model releases. The number one spot is volatile, leapfrogging between vendors. Watch what happens when we map these models against strict enterprise safety standards. The raw intelligence stays high, but out-of-the-box compliance is much lower. This highlights a serious disconnect. Real organizations don't actually buy a single model. They build AI applications, and those applications have to fit inside complex, heavily regulated business systems. Hardwiring your company's entire infrastructure directly to a single vendor's API feels fast on day one, but it creates a brittle foundation. If that provider raises their pricing, or the model's behavior drifts, or you fail a strict audit, you are trapped. Chasing the absolute smartest model for every single task creates a massive pile of technical debt. For an enterprise, the real challenge is building an architecture that survives the next inevitable model update. The alternative to that direct vendor lock-in is a multi-model platform strategy. Instead of treating every model provider as a separate integration project, tools like Amazon Bedrock act as a managed control plane. It sits directly between your enterprise operations and a whole menu of different foundation models. This requires a clear trade-off. You give up the unrestricted, frictionless speed of prototyping directly against a raw API, and in exchange, you gain an enterprise-grade governance layer that applies to every model you use. You build your security rules, data access policies, and routing logic into stable interfaces once. Then you plug different models into that established system. By adopting a model-agnostic control plane, you protect your architectural freedom. When a cheaper or faster model hits the market next month, you can swap it in without rewriting your entire application. Think about how logistics companies operate. They don't use an airplane for every delivery, use cargo planes for long distances, trucks for heavy freight, and vans for local drop-offs. AI tasks require that exact same practical matching. This brings us to multi-model task routing, which is an essential financial strategy for running AI in production. Most corporate workloads consist of high-volume, low-complexity tasks. Think about summarizing millions of routine customer support tickets or formatting product descriptions. Then you have low-volume, high-complexity tasks, like deep reasoning for legal policy interpretation or generating complex code. This split flowchart illustrates the difference. On the top path, processing every single daily task through one premium model causes the cost counter to spin aggressively. On the bottom path, a Bedrock router dynamically sends the massive volume of routine tasks to a basic, cheap model and reserves the premium model only for the complex edge cases. The top single-model approach overheats your budget fast. Multi-model routing drastically reduces your unit economics and your latency. But to get this efficiency, your engineering team has to do the heavy architectural planning upfront to accurately classify these workloads. For enterprise-scale operations, implementing a multi-model router is the only realistic way to make AI financially viable. Otherwise, you are severely overpaying for basic digital labor. Cost optimization is critical, but it is not the primary roadblock for bringing AI into production. That belongs to security and compliance. When employees or internal apps send proprietary company data out to unmanaged public AI APIs, you risk immediate data leaks. To prevent this, AWS Identity and Access Management, or IAM, serves as a mandatory gatekeeper.
It explicitly defines which user or application is allowed to call which model and with what specific data. We can see how this governance works in this architecture schematic. A prompt originates here, completely inside a private corporate network boundary. Before reaching the model, the request must pass through strict IAM checks and natively encrypted data using key management services. For highly regulated industries, this setup enforces a strict zero retention policy. Bedrock ensures that your inputs and outputs are never shared with the model providers or used to train the base models. Developers often push back on this at first. Adding this layer of governance eliminates the speed that tech-forward startups enjoy, but you gain mandatory auditability. Services like CloudTrail create a time-stamped, unalterable log of every single model call and data access event. These strict, invisible controls are what take AI from an untrackable IT shadow risk and turn it into a regulated capability that healthcare providers and financial institutions actually trust. A highly governed zero-retention model is incredibly secure. The problem is, it is also completely ignorant of your company's internal data. To make a secure AI actually useful for specific internal operations, architects rely on retrieval-augmented generation, or RAG. Instead of hoping the model somehow memorized your company's proprietary rules, RAG fetches your exact approved source material at the exact moment of the request. This flowchart shows how that happens. When a user asks a question, the system first queries your internal database. It extracts the exact policy document needed and pushes both the document and the original question into the AI to produce an answer with citations. Look at the difference in the output. The ungrounded model tries to guess your business policies and hallucinates. The RAG output anchors its answer directly to a cited paragraph from your actual manuals. The operational trade-off here is significant. A successful RAG architecture demands dedicated data engineering and perfectly clean internal documentation to function well. If your internal data is a mess, your AI will be too. By pulling exact source material, RAG shifts the AI from a creative brainstormer into a strict, auditable operational assistant that eliminates guesswork. So you have to make a choice. Do you connect directly to a single model's API, or do you build a managed multi-model platform layer? To figure out which approach makes sense for your team, let's look at this decision tree based on your primary operational constraint. If you are enterprise IT or in a regulated industry, compliance is your constraint. Adopting a managed cloud ecosystem with native identity controls is non-negotiable. The trade-off is that while you will pass your strict GRC audits, you must commit deeply to configuring and maintaining that AWS infrastructure long-term. If you are in high-scale retail or operations, your constraint is unit economics. You need multi-model task routing so you can optimize millions of daily transactions without draining your budget on premium API calls. Finally, if you are a tech-forward startup or an indie hacker, your primary constraint is speed to market. Direct API integration lets you prototype and ship features almost immediately, but you carry a massive risk. Shipping fast today means you will eventually hit a wall when your first major B2B client demands the strict security controls you skipped over. Choosing your architecture is not about finding a universally right or wrong answer. It is about matching your infrastructure to your specific risk tolerance and your long-term scale requirements. A flashy demo will always succeed without controls. A production system cannot. In the real world, the enterprise AI race is won by operational maturity, robust security, and careful architecture, not just the highest leaderboard score. Don't marry a single model. Build a platform that lets you date them,